This is our second video beyond the intro, where we've already accomplished the design in the last video here in part one, and we've got all of our base components of our machine, and now we're going to start creating those each definition of these components based off of this rough design, this abstract design. Again, this could just as easily be a model of your exact machine and every measured part. So before we get too far into this, it's easiest to work from a 0,0 origin. This isn't lined up to that, and I want to make sure that we go ahead and do that before we really get into a place where we start to make the definitions. That just makes things a lot easier. So I'm going to move this from its lowest left point. Go ahead and turn on our object snaps here. Grab that, just type in 0, 0, 0, get it to the origin, and now everything should flow real smooth from there. So, got the parts. Open up Grasshopper. I'll go ahead and close it just so you see me open it, so you understand how to get it open. Start typing Grasshopper in the command line, hit enter. Grasshopper launches, and mine's already minimized, so there we go, because that's the way I last left it. But it should pop up for you. So go ahead and open this up. I'm going to make sure nothing is selected here at this point. And what we really need to do is we need to define our different components. So we will describe those now. Our two rails are the only thing that really don't move. They stay exactly where they are. But we will define those. So I'll select those two. I'm going to grab our BREP collection, which is really just 3D solid geometry. And I'm going to say set multiple BREPs. There we go. And those turn green. That means that when I highlight this, that's I can tell that I have the volumes of those component parts, and I can give this a name. I'm just going to call this rails. Okay, and those are set. The other thing that I would like to do is just right click in here and say internalize the data. When I internalize the data, I can delete the actual objects out of the design here. They're gone, but it still is remembered by definition what is in Grasshopper that makes up those volumes, because it extracted all that information. So now Grasshopper is fully aware of what those rails are made up of. So we can move on. The next one is our gantry bridge. What I'd really like to do is just union these together. They're not going to move apart from each other. It's going to make the actual definition a lot easier to deal with in Rhino. I just don't want to deal with 3 separate parts. It's just unnecessary work in here. So I'm going to go ahead and just grab all of these. And in Rhino, not Grasshopper, but in Rhino, I can just say Boolean union, hit enter, and that created one object out of that, which is great. So instead of having to deal with 3, I deal with 1. I'm going to go ahead and name this. I'm going to name this gantry. And I'm going to set that as my 1 BREP. There we go. Now when I highlight it, it's green. And when I come over here, I can delete it. I'll make sure I'm in the Rhino, not Grass. I don't want to delete that component. Delete. Done. You see, that went away. I made a mistake. Control Z. If I right click on this, remember, always have to internalize the data. That way, when I'm over here in delete, we want to make sure that definition stays. That tells us we did the process correctly, and we can keep moving on from there. Okay, the other 2 main parts that I have here are what I'm going to call the Z plate. It's the plate that will move in X, but it will normally have some big fixture up above or whatever with a motor and a lead screw that will drive this motor and tool up and down in the Z-axis. So I didn't draw all the motors and that sort of stuff for ease of whatever, but just realize that this is representative of that, and you should be able to apply it to your specific need. This is just very simple, simplistic, abstract, but just as powerful as if you built your own machine in this way in Grasshopper, being able to just move it around and control it according to your needs. So with that disclaimer, that represents that big old assembly of lead screw and stepper driver or stepper motor or a AC servo or something like that. That's what that represents, that little square block. Okay, so add a new brep, right click, set one brep, perfect. Internalize the data once again, come back out here, delete it. That block is still there. We know we have it represented as a definition. We're done. Back out here, I'm going to Boolean union these together because in this case, I don't want to deal with the complications of the tool separate from the motor. There's no doubt times where you're going to want to for things like tool changes, automatic tool changes. If that's what your machine can handle and do, you're going to want to do a whole lot more detail for tool holders and collets and all sorts of things. So anyway, that's good. Pull up another brep, place it. I forgot to rename these, but that's okay. We can always go back and do it. Motor is good enough for now. Right click, set one brep. Come back, internalize the data, click on this, delete it, and there we go. I'm going to call this my Z plate. I said I would, now I will. Z plate. And it's just visuals for me to know what is what while I'm working with these things. So I have all those. Now, for what we need to figure out in this whole definition is limits. I highly doubt we want this gantry to come out beyond the rails, because physically that wouldn't work. That would ruin your machine physically if that were to physically happen. Same thing, we wouldn't want the Z plate to come and crash into the side of the gantry here. It's going to have a limit on the lead screw or belt or whatever that's on. It's going to stop at a certain distance or hit a limit switch at a certain distance. So we just want to set the limits of all of these movements. And then when we have the limits of that, we work within those and everything will flow from there. The other thing we need to establish is relationship of movement. This gantry can only move, this three-parted gantry, what's highlighted in green, can only move in one direction. That moves in the Y direction. Now, what has to follow it is the Z plate and the motor in that direction. It's going to move with it in Y. So we need to make sure that that and that rails don't move. They're going to stay stationary. The gantry is going to move on the rails. It's going to move in the Y direction. The Z plate is going to follow that Y direction, and the motor is going to follow the Z plate because it's attached to it, and that is attached to the gantry. So all three of these will move in the same Y motion. Now, that being said, the Z plate itself will move in the X direction along the gantry, and the motor will follow it. And then the motor itself will be the thing that moves up or down in the Z direction. So that will have to have the Z motion. So we just need to make sure that we understand those relationships. And once we do, we can program those relationships right here into the Grasshopper part of this definition. So to get that to start moving, let's go ahead and move. We'll apply a move. So the easiest way to get that is you can double click, type in move, and you get a list of all these things. We just want the normal move. And it's kind of weird because in Rhino or like an AutoCAD or those that kind of operation where you type in move, you're actually moving the geometry. In Grasshopper, you're actually copying it. So there is no move or copy in the traditional sense. It's always a copy. But what you can do is you can take that and you can disable the preview of that, and you can see that there is a default. It's going to move 10 units up. I drew this thing at an arbitrary scale, so it's really, really small. But it's going to move 10 units up in the z-axis, which that's a default. I don't really want that. That's okay. I'm going to turn back on the preview so we see where original's at this point. But I know that our limits are basically where I've placed these. I try to draw the limits of where this is at its lowest y value possible. So I'm going to call that machine 0 for the y. And I'm going to say the same thing for the x, that's as far left. I'm going to call that x0. And in our cases here, I'm going to call that z0, machine z0. And that way just everything is, we're just going to move in the, I shouldn't call it positive on the z, but we're just going to move forward from there. We're going to take its current location, call those its minimums or maximums in the z-axis case, and it just makes life simpler moving forward. We don't have to deal with the other direction for customization. This is its home position, machine home position. Okay, so how do we take this move? The easiest way is it's a 3-component set, 2 of the same component. It's a XYZ value that forms a point object. We do 2 of those. And to get a vector, it's just the easiest to create a 2-point line. Let's see, we do a primitive, there's a 2-point line right there. It will actually draw a line. It'll draw 2 points and a line. They don't really get in the way, but they're there. Both points are in the same location. It's a 0 length line. This thing didn't move whatsoever. So I'm just going to move these out of the way a little bit down, and we're going to plug in the y direction because we want to affect the y on the gantry. That's the only way the gantry moves. Okay, so I'm just going to start. I know 10 was like way out of range, so I'm just going to start with 5. And we're going to put that there, and you'll see that wasn't too bad. It actually worked out. Probably want to go a little bit more than that. 6 is probably too much. Yep. So the easy way to get more granularity on these slider controls is right-click on it, go to Edit, go to Real Number. I want to make sure that we're looking 4 decimal places deep. That's probably more than what we need on this. And we want to set our limit to, I don't know, max range to 5.75 or something. Okay, and just play with it until, too far. Okay, so let's just say 5.6 is our max. Stuff's a little shy, but that's okay. I'm just going to use that value, assuming that it just can't travel beyond it. So 5.6, set it, hit OK, now we're done. Now, no matter how I move this, it's not going to come off the rails. That's the important part. Okay, zoom back out of this, zoom back out of this. All right, now what we're still seeing is our original definition. We can just turn off the preview on that. And now the only thing we will see move is that gantry. And of course the point and the line, because it's a 2-point line there. You can ignore that. We can turn off the preview and all that. It doesn't really matter. It's just there to form the vector of the move. So from 0, 0, 0 to 0, 5.6, 0, that is the movement only in that y direction, 5.6 units, or however, whatever is in between that. Okay, very similarly, I'm going to want to really move all of these that direction. So the easiest way is probably just to flip this around, put this up. These little path lines seemingly get in the way, so I'm going to put those up there. And if I drag these and I hold the shift key, you'll notice my cursor changes. It goes from just a normal arrow to a plus. Plus just means add this input to the input that's already in this slot. So it doesn't take away that. If I were just to grab this and drop it, it dropped these other two. So you do what you want to do first. Then on the next ones, you hold shift, plug it in, and it'll just continuously add whatever you place into there. So we know that the Y value is controlling, or the Y movement is grabbing everything we want to move, which is the gantry, the Z plate, and the motor, all in one operation. And that's great. That's exactly what we need. So let's go ahead and shut these off. We don't really need those anymore, but we need to get them back. We need to get them back into controllable units or items again. So we're going to just shut each one of these off. They're there. They're not going to go anywhere. We still have them. They're just not going to display in their original location because we've needed to drive them along with the gantry. So what do we have in this move component? Well, that component, that at least geometry-wise, is made up of all three of these. And in a list form, and I'll go ahead and just pop open a text panel here. In list form, we have, I'm going to just say 0 gantry. I'm going to say 1 Z plate. And then we're going to say 2 is the motor, or should be. It might not be exactly that, but it should be. So that is a list, and that list starts with index of 0, and that would be the gantry object because that's the one we added first. The Z plate we added second, and the motor we added third. So they should be in that order. Sometimes it doesn't go that way. But yeah, that's what should happen. So let's look at this. So we see index 0, 1, 2. And it's made up of 3 BREP objects, which is great. Gantry is an object, the Z plate's an object, the motor's an object. Perfect. Okay, and that list doesn't need to be that big since we're a little tight on space here. Anyway, so to get at these different index values, again, we don't need to control the gantry anymore. It's already being controlled by this one, and that's all we need to move for the gantry. But we do need to get back at these last 2 items, which should be the Z plate and the motor. And to get those, we just go after sets. So here's how to deal with lists. And this is a list of objects in the geometry list. And we can get the nth item of a list. Well, the nth item is whatever we set this index number to. So we're going to set the list to be this geometry list. The item we need to get at is item 1 and item 2, which is the last 2 in the list that we've added here and here. So I'm going to go ahead and set this number by the integer to 1. And when I highlight that, there we go. It's exactly as expected. That is the second thing I've added to this geometry collection list. Okay, so I'm going to go ahead and copy this one and paste it because it's the same list. And I'm just going to change this integer to the index number of 2. And there we go. So now I have my Z plate back again, and I have my motor back again. And we don't technically need that, but I think it's good to have that as a visual so you understand, like, we ignored 0, which was the first item in the list, and we need 1 and 2. So it just helped us to say, what is that integer number? Well, that's 1. That's 2. It just keeps things a little more clean when you have to go back and troubleshoot anything, if for any reason you have to do that. All right, so I'm going to copy these things again because these are just components we're going to use to move in the X. We're going to disconnect that and add another input for the Y coordinate. For the X coordinate to move these this way. So Control C, paste it again, kind of let it remembered its old connection. We just need to disconnect that one. And I'm going to go ahead and probably just grab another slider. 5.0000. That way, it should, when we type in that decimal number out to that many zeros, it should just automatically set the type, the type to be a floating type number instead of an integer, and based on the number of zeros, it should have automatically, which it did in this case, it should have automatically gave us that number of digits beyond the decimal place. So I'm going to set this. Well, let's figure out the limits on this first, and then we'll set the max on that. So let's go ahead and put that on the X, and then we're going to want to do this move, and I'm going to want to get this whole thing again, but that's okay. We'll just copy this for now. We'll paste it. Again, it's remembering its inputs. So what we want to do here is use this as a translation vector, but the geometry that's coming out is going to be here, and hold shift, remember, to get that plus sign, and here. So that is the part we wanted to move in X. So that's what that will do. But we also need to set the limit because it can't go crashing through and fly off the machine like that. So we just need to, I don't know, maybe look at the front view of this model, figure out what's a good safe limit. Maybe that's it. You know, that looks about right. So why don't we call that 4.95? On the edit the values, we have this max range. Double click it, 4.9500. We still want to move it with that many digits. Okay, so we'll call it good. That works all the way to our resting point, and it's not going to go beyond that way. And we can tell by just moving it slightly, it'll stop completely at 0. Okay, and then we want to go back through here, and we want to turn each one of these off because the new definition is here, and now we're not left with that. Oh, sorry, we're also left with that here. So what we want to do in that case, I want to just add a new list item. It defaults to 0, so it's the right item in the list for the gantry here. And that should be the only thing that shows up out of here. And then we want to take this whole definition of all these objects, because I don't want to necessarily kill that without having that 0 item there. And there we go. We don't have that ghosted motor and Z plate anymore. It's a brand new looking thing. Okay, so let's rotate around that. You'll see everything is just kind of in working order, at least on the Y and X values. So we're just going to repeat the process one more time for the up and down Z movement of the motor and the tool, and we'll be done. I'm going to go ahead and set this to top view one more time, just so you're seeing the world orientation of these axes. And let's go ahead and finish the Z real quick. And then we have one more video after this, and it's really just to cover how to wrap all this stuff up into the components and to get to the final output you saw there in the initial demonstration video, introduction video that showed the final output of what we are doing here today. Sorry, I got an itch in my throat. Okay, moving along. Hopefully moving along. Okay, so I know that now we have 2 objects, so it should be item 0, item 1. So I'm just going to copy these because I know those integers are set. Move them over here, and I'm just going to set the list to be this new thing here. I'm going to copy all of this. Okay, and I'm going to shut this one down. I don't want to see that anymore, but I know it's going to be visible here. And then what we're going to want to move here is this guy, but we're not going to want to move it on the X. We're going to want to move it on the Z axis. So I think if I hold Control, there we go. If I do Control Shift, I'm able to move the input, and that updated to the Z coordinate. The problem with this particular one is I don't want to go up. I only want to go down, and as you guys know in CNC land, that Z up is positive, so it's doing the right thing. However, when I move this, when I want to increase my Z value, in this case, I can do one of two things. I can, and I probably want to do it this way for sake of correctness, is I want to edit this and set my minimum value to the negative minimum, and then machine 0 is already its resting position. Or I could do something completely lazy and wrong, and just multiply this value times the -1 and watch it drop down, and that's okay. But I don't really want to start messing with my understanding of a positive input going in a negative direction. That won't follow G-code. And if you ever had to parse out G-code, you'd have to be certain you multiplied it times that negative value to watch this go down properly. And if you multiplied it in the wrong direction, you're going to keep fighting the limit switch on your home, on the home position of the Z-axis. So this is just the easiest way to deal with this, is to set your maximum as being 0 and your minimum as being whatever we want as a minimum. I'm going to say -2 in this case, and I'm going to set the maximum as being 0. Okay, so that so far is correct. Oops, not grabbing the slider. And then we just want to slide that. 2 is way too far, at least for the visual relationship of this small, dinky, abstract machine. But let's bring it up to what it should be. I don't know, maybe it'd come down about that far. We might start milling into our table or something, but it doesn't matter. So I'm going to say it's -0.9. Set the value. We want to set our minimum. -0.9. Accept that. Commit the changes. Now, I'm not going to go beyond those limits. I might need to home to something like that if I have like to a top of spoil board or something like that, or top of material, depending on your approaches to milling. But yeah, that's basically how we set those. Now we can control this whole machine, and it's good to go. It's ready. So next video, we're just going to polish this up. We're going to polish all of this up. I'm going to show you how to get it into its own component, and then how to instance that component to where you can use it anytime you want to from here on out. So once you have your particular machine defined, and it's got all of its definitions in here, and it's moving exactly to the limits that you need it to move, this thing is just, with a little bit of polish, it's ready. It's ready for you to use every time you need it. So that being said, I'm going to stop that here, and we'll see you in the next video to finish this up.